Welcome to this video. My name is Darshan and Katgeri. I am working with Jain College of Engineering, Belgaum. In this video, we will be solving a problem on tetrahedron, which means it is a triangular pyramid. All the faces of this solid are equilateral triangles. Let me just show you the visualization so that it will be more clear. You can see that this is an triangular pyramid. If I show you the top view of this, you can see that there is one base ABC, and there are three triangular faces, and all of these, they are equilateral triangles. Also, it has an axis. In the front view it will be much more clear. In this view, it has an axis. This is O1 and this is O2. Also observe that O1C is an edge which is parallel to the vertical plane. In the isometric view, you can see that O1C is parallel to VP. Let's go back to the presentation. So a tetrahedron is an triangular pyramid in which all the triangular faces are going to be equilateral triangles. Let us go through the problem. A tetrahedron of 55 mm sides rests on one of its corners, so it is resting on corner, such that edge containing that corner is inclined to HP at 50 degrees and to VP at 30 degrees. So in this, the inclination is with respect to the edge containing the corner, which has to be noted. Draw the projections. Let us go back to the visualization. We are talking about edge O1C. So this edge has to be inclined at 50 degrees to HP and 30 degrees to VP. So we have to rotate this clockwise such that this edge O1C is at 50 degrees to HP. So let us see how to do this. Let us start the problem. Draw the XY line, mark VP, HP. Draw the top view, which is an equilateral triangle of 55 mm sides. Mark the center. You can take this corner A1, A, and join it to the midpoint. This corner B and join it to the midpoint of AC, and you can take C and join it to the midpoint of AB. And you will observe that all of them will intersect at one point, and that point can be taken as the center. And once you get the point, this point will be O1 and O2 will be in bracket because that is on the base. So you have to join all of these slant edges. Next you have to take the projectors. Notice here that the length of the axis is not given, and it will not be given for a tetrahedron. So how to construct this? To construct this, we have to first of all O1C is an edge which is parallel to the vertical plane. Okay, so O1C is parallel to the vertical plane. So what we have to do here is, from this point C, we have to measure 55 millimeters and we have to draw an arc. So what I mean is, you first spot this particular point, and from here you draw one line of some finite length, and from this point, this is the point C, measure 55 millimeters and cut this axis. So you will get one point. You measure 55 millimeters and you cut this particular line. This point is point O1. The axis length is not given. So this is how you have to construct the front view. Take 55 mm and O1C. This is the edge which is parallel to VP. So from this point C, take 55 mm and cut this particular line, and this edge, this point will be O1, and then draw the axis and complete this view. So this is the front view of this tetrahedron. The axis length is not given, please note it. Name it accordingly. The next step is that the slant edge is 50 mm. So we have to now draw this. To draw this, mark a point C dash at some convenient distance, and you have to draw this edge C dash O1 dash such that it is inclined at 50 degrees with respect to the horizontal plane. Yes. So you draw one line 50 degrees to horizontal plane, that is to XY line in this case. So C dash O1 dash, you have to measure C dash O1 dash from this view, and you have to mark here. Then you have to measure C dash A dash B dash, and you have to mark one arc. Then you have to measure O1 dash A dash B dash, and from O1 dash you mark another arc. So you, wherever these two arcs intersect, you will get one point. That point is A dash B dash, and you have to join these two lines to get this particular view. And from C dash you can measure O2 dash and mark an arc. So, and this will represent the axis. O1 dash, O2 dash will represent the axis here. The next step is to obtain the apparent top view. The steps are similar. Take the projectors and join the boundary lines. Here again you will notice that this point C dash is the farthest point from the observer. Observer will be here. So from here C dash is the farthest point. So whatever is going to start from this point C dash, they are going to be hidden lines. So what is starting from point C dash, which is nothing but point C here. So we will see what all are starting from this point C. CA, CO1 and CB. These are the three lines starting from point C. So all those lines, they will be hidden lines because this is the farthest point from the observer. So mark that point and join these lines. They are going to be hidden lines because C dash is the farthest point. Let me show you the visualization. Yes, like this. So we have drawn one 50-degree line. This angle is 50 degrees, and you can see that this is O1C. O1C. This edge is inclined to VP at 50 degrees. So this inclination is 50 degrees, and we have drawn this particular view, that is this particular view, and the top view, that is this is the top view. If I switch on this mode, it will be more clear. Point O2 is the point C. Point C is the farthest point. So whatever is starting from that, it will be hidden as it is observed here. You can see that. You can see only this face and nothing else is visible. Okay. The next step is that the edge containing the corner is inclined to VP at 30 degrees. So which is the edge containing the corner? We are talking about edge O1C. We are talking about edge O1C. So this has to be now made inclined at 30 degrees to the vertical plane. So what we are going to do is we have to first decide whether to solve this by direct method or by locus method. So let us see how to do that. Now the actual length of this is 55 millimeters, which is given. Okay, that is its true length. But in this view, we observe that this length has changed. It has become less. And this inclination is the true inclination because it is told that it is inclined at 30 degrees to VP. So we have the true inclination, but this length is not the true length. This length is the apparent length. Okay, that is O1C is the apparent length. So we have true inclination and apparent length, and apparent length cannot be plotted on true inclination. To plot this apparent length or draw the apparent length, we need the apparent inclination. So in this case, we have to use locus method to obtain the apparent inclination. So to do so, what we will do is we will mark one point. We will mark one point here, and we will take this measure, that is O1 dash C dash, mark an arc, and through that arc we will draw one locus, and then we will measure O1C from this particular view, and from the initial point which we had selected, from there we are going to cut the locus. So wherever the arc cuts the locus, and from the point which we had marked, we will draw one line, and we will extend the line such that it intersects the XY line. This angle we obtain is nothing but the apparent inclination. Now we have the apparent length, and we have apparent length here also, apparent inclination here. So now we can plot this. So this has to be redrawn here on the apparent length line. You can see that here we have point O1, this is point O1, and we have this point, this is nothing but point C. So from here we can measure O1A, and from here we can mark O1A. At the same time we can mark O1B also here, and we can then measure this from here, that is CA or O2A. From this point you can mark and cut an arc here, and at the same time cut the arc here also. So you will obtain these 2 points, join these lines, and redraw the same thing here. The next step is to obtain the final front view. The steps are again similar. Take the projections from all the points. Here you will see that the base is visible because it has been turned. Let me just go to this next scene. Yeah, here. So this is what we have to obtain. This is what we have to obtain, and we see that the base is now completely visible. This is the base in blue color is the base. The base is completely visible to us. Okay, so we have drawn the base, and this point O1 is here, this point O1 is here. This is the axis, and again what I insist to draw this final front view is that first mark all the points and draw the boundary lines. Boundary lines are always visible, as you can see in this case. They are drawn with continuous lines, and spot the farthest point. In this case A is the farthest point, so whatever is going to start from A is going to be hidden except for the boundary line. So what is starting from A? AC, AO1 and AB are starting from point A. So we can see that AC is already drawn. It is a boundary line. AB is also a boundary line. So that is why they are drawn in continuous lines. And this AO1, it is not a boundary line, so the line joining A dash and O1 dash has to be a dashed line. So this is a complete solution of this problem. Also, if I go back to visualization and switch on this, it will be much more clear. You can see that this is the point C. It is resting on, say, one of its containing corner. Okay, it is resting on one of its corners. You can see here, such that the edge containing the corner is inclined to HP at 50 degrees, that is this particular view we have drawn, and to VP at 30 degrees, that is these two views. So this is the complete solution. This can be solved on the grid sheets. Thank you.